Guys, equations, a word that intimidates so many people. Today we're going to break down equations. Welcome to Numbers Off the Hook. This is equations part 1. So when we talk about equation, guys, this is not something scary. What we say is, here's an algebraic expression, right? And is equal to another algebraic expression. So two algebraic expressions are equal to each other. That's an equation. And the best way to learn about equations is to do a lot of examples. That's the only way to learn. So we start with this. Let's say we have x minus 4, right? This is an algebraic expression. It has variables, x, it has operators, minus, and it has numbers, 4. So this is an algebraic expression and is equal to, let's say, 10. Now this 10 is also an algebraic expression. It doesn't have a variable, it doesn't have an operator, it only has a number, a constant, 10, but it's still an algebraic expression. So these two things are now equal to each other. And our goal is to solve for x. And when we say solve for x, what do we mean by that? It means what we want to do is we want to isolate x. Okay? That's what we want to do. So here we have x minus 4. So we want to get rid of the minus 4. So to get rid of the minus 4, we do the opposite operation. We call it the inverse. We do the inverse. The inverse of minus 4 is plus 4. So if I write x minus 4, then I write plus 4. Okay? Plus 4 is the inverse of minus 4. But if I add 4 on the left-hand side of the equation, I have to also add 4 to the right-hand side of the equation. So I have to add a 4 here as well. So what we did here is we took the equation, right? And we added 4 on each side, on the left-hand side and on the right-hand side. And the reason we have to do it on the both sides is that the equation always has to balance, right? If I do something to the left-hand side of the equation, I have to do the exact same thing to the right-hand side of the equation. Okay, cool. So what do we have here? Now we see the magic here. This minus 4 and plus 4, they cancel out. So these guys cancel out. They cancel each other out. So we only remain with x. And that's equal to 10 plus 4 is equal to 14. So we've isolated x. X is by itself now on the left-hand side. And on the right-hand side we have 14. So now we know that x is equal to 14. So we have solved the equation. We figured out what the variable x true value is. Okay, so here I've written another equation. Here we have minus 5 is equal to x minus 5. But wait a minute, Alid, the x is on the right-hand side of the equation. That's totally fine. X could be on either side or on both sides of the equation. It's still an equation, okay? And our goal is to isolate x. So now we want to get rid of the minus 5 because then x is going to be by itself on the right-hand side of the equation, and then x is isolated. So what do we do? Well, the inverse, right? The inverse of -5, the opposite, right, is +5. So what we're going to do is, we have -5 here, we're going to add +5 on both sides of the equation. So we're going to add 5 here, and then we're going to add a +5 here. Okay guys, you follow me? We just wrote the same thing, but we added 5 on both sides. And now the magic happens, because now we can see here that -5 and +5, it cancel each other out. This is equal to 0. So on the right hand side, we have only x remaining. And that was the goal, right? X is isolated. On the left hand side, we have here -5 +5, that's also equal to 0. So we have 0 is equal to x. Or we can say simply x is equal to 0. So that's funny. X equal to 0. Can a variable be equal to 0? That's totally fine. A variable can have any value, including 0. Okay, in this next example, we have the following equation. We have k plus 5 is equal to 7. But wait a minute, there's no x here. What's going on? Well, a variable can be any letter. It doesn't have to be just x. It could be a k, it could be a b, it could be m, a w, it doesn't matter. So in this case, we want to solve for a k. So k is the variable. And we see have k plus 5. We want to get rid of that 5. And the inverse operation of +5 is -5. So we're going to add -5 on both sides of the equation. So what do we have here? We have k plus 5. And then we have -5 here. And now, since we put -5 on the left-hand side, we also have to put it on the right-hand side of the equation. So it balances. And now we see here the magic, +5 -5. These two things cancel out. So this is going to be equal to 0, right? So we only remain with k. And on the right-hand side, we have 7 minus 5 is equal to 2. So the answer is k equal 2. So this is nice. And when we solve equation, it's nice to have the equal signs in a direct vertical like this. It makes the calculation look cleaner. Okay? So don't keep meandering. Try to keep the equal signs in a straight vertical line like this. It's going to make it look cleaner and it's going to be easier for you guys. And now in this example, we have 6 is equal to x minus 2. So here again, x is the variable. So we're going to solve for x. So what's the opposite of -2? We're trying to get rid of the -2. It's obviously +2, right? So we have 6 plus 2 is equal to x minus 2 plus 2. So if I add 2 on the left-hand side, I add 2 on the right-hand side, right? Now these two things cancel each other out, right? So we only have x on one side. On this side we have 6 plus 2, that's equal to 8. So we have that x is equal to 8. Okay? Straightforward. This should be easy now, guys. So we are solving equation by adding and subtracting numbers, right? Now I want to show you guys another trick. We can check whether our solution is correct. And this is how we do it. This is how we check our solution, right? Let's look at the right-hand side. On the right-hand side of the equation, the right-hand side, it was equal to x minus 2, right? X minus 2. Now, let's plug in our solution. X is equal to 8. Then we have 8 minus 2, right? 8 minus 2 is equal to 6. And if we check, 6 is equal to the left-hand side of the equation. So in summary, we have that the right-hand side of the equation is equal to the left-hand side of the equation. So this solution, x equal 8, is okay. It's all good. So that's how we check our solutions. And finally, guys, we're going to end with this. Here we have x minus a third is equal to 2/3. Okay? So we want to get rid of minus 1/3. So x will be by itself on the left-hand side. So how do we do that? Minus 1/3, well, the opposite, the inverse operation is going to be plus 1/3. So we just add plus 1/3 on both sides of the equation. So we have x minus a third plus 1/3. And then we have 2/3 plus 1/3. Right? I added 1/3 on the left-hand side, and I added 1/3 on the right-hand side. Okay, let's evaluate. These two things cancel each other out. So we only have x. Here we have 2/3 plus 1/3. That's equal to 3/3. But a number divided by itself is equal to 1. So x is equal to 1. Okay? Sometimes, guys, it's tempting to write here equal to 1. Don't do that. Always keep that beautiful, nice vertical. Always keep it like this, nice and clean. That's going to prevent a lot of unnecessary mistakes, okay? Now, the last thing we do is we're going to evaluate, we're going to check our solution, whether it's correct or not. Okay? On the left-hand side, we had x minus a third, right? This is what we had. This is how we started. X, we say, is 1, so it's going to be 1 minus 1/3, right? That could be written as 3/3 minus 1/3, right? 1 is equal to 3/3, which is equal to 2/3. But that is equal to the right-hand side of the equation. So the left-hand side of the equation is equal to the right-hand side of the equation. So our solution, x equal to 1, is okay. It's been approved. Well, thank you guys for watching this video. Please hit the like button. And in the next part 2, we're going to step up the game. It's going to get more difficult. So please follow along and let's do this, man. Have a nice one.